Hello everyone, welcome back to Data Science Lovers. In today's project number 15, we will cover a complete quick commerce data analytics project with Python. We will explore the synthetic real-world style data that we created in our last video, and on this dataset, we will perform data cleaning, EDA, visualization, and we will build a mini dashboard to uncover the meaningful insights from the data. If you are learning data science or data analytics, then this project will be a base project for you because in this project you will learn almost everything that will cover data analytics with Python. So let's start. First of all, we will import the required Python libraries. For this project, we will import the pandas library, numpy library, matplotlib, seaborn, and we will also use the plotly library to draw some attractive graphs. And we will run this. The libraries are imported. Next, we will load the dataset in this Jupyter notebook. I will save the dataset in DF. As our dataset is in CSV format, we will use pd.read_csv, and here we will paste the path of our file. This is our raw dataset, or you can say unclean dataset. I will copy its path and we can paste here directly. When you will run this, it will show Unicode error. You can simply remove this by putting small r here and run it again. The data is loaded, and have a look at our dataset. Here, this is our dataset that we will use for this project. In this dataset, we have 1 million rows and 13 columns, starting from order ID column and till delivery partner ratings. Now let's check some basic structure of this dataset. For this, we will use the info function. So df our data frame dot info function and running this. It will show the basic information about our dataset. And here we have 1 million entries. The indexes are 0 to 99999. Okay, and there are total 13 columns. These are the column names, and it is showing the non-null count, means how many non-null values are present in each column. Here we can see in the city column we have less non-null values. It means there are some missing values in this column. Also, there are missing values in item counts column and in customer rating, and at last in delivery partner ratings also we have missing values. These are the data types for each column. The order ID is in integer format. We have to change it into string format, and these are the other data types. Now we will check some statistical summary of this dataset using the describe function. Our data frame dot describe function and it will show the statistic summary of all the numerical columns of this data frame. Here you can see, as of now, our order ID is in integer format, means numerical column, so it is showing the summary for this column as well, but it is not required. Here, if we consider customer age column, then the mean customer age in this data set is 38 years, and the minimum is 18, and the maximum is 59. Similarly, the mean order value, here we have this, then standard deviation, then minimum order value, and maximum order value. Then we have delivery time in minutes, distance kilometer, and item counts, customer rating, discount applied or not, and delivery partner ratings. Now let's check for the missing values in this data frame. As you all know, for checking the missing values in a data frame, we have two functions. First is null and second is na. So we can use any of these functions. On this data frame, I will use isNA function dot sum. It will show the sum of all missing values in each column. Here you can see in city column we have 52,000 missing values. In item columns we have 35,000, customer rating 47,000, and the most values are missing in delivery partner ratings, which is about 1 lakh. In case you want to see the records where we have missing values in this data frame, then for this we can use isNA function, and on this we have to use any function. Using any function, it will show all the records where it have at least one value missing in that particular record. Okay, inside any function we have to pass x is equal to 1, and we have to put this whole syntax in square brackets like this. And to show the record in data frame format, we have to pass our data frame in the starting. When you will run this, it will show all the records where we have at least one missing value in any row. Here you can see in item count we have this missing value. It is showing by NaN, not a number. Okay. Similarly, for index number 6, if we check here, then we have missing value in delivery partner rating. And at the last index, here you can see that we have missing value in item counts column. Okay. So there are total 2,19,000 rows where we have at least one missing value. Now if you want to check those rows where we have all missing values in every column, then simply you can copy this and paste, and instead of any you can use the all function. When you will run this, it is showing no output, means there is no row where we have all value missings in each column. Okay. In case if suppose this particular row all the values were missing from starting to end, then this row will be shown here. Now we will start handling these missing value in each column. We will start by our first column, the city column. In this column we have 52,000 missing values, and as this column is of string or category format, so we cannot put the missing values with mean or median of this column. So we have to simply remove all these 52 records from this data set where we have the missing values. We will drop those rows that have missed value in city column. For this we will use the dropNA function on our data frame, and our data frame, here we will use the dropNA function to remove the rows. And inside this dropNA function, as we have to consider the city column only, so we will use a parameter which is subset. Subset will consider a single or multiple columns at once. Here we have to consider only city column. I will pass subset equal to city. Okay. And when we will run this, the command is executed. Now in city column we don't have any missing value, and you can also see the difference in the number of rows. Now all the 52,000 rows are removed here. We will save this result in our actual data frame, and df equal to this one, and the command is executed, and this is our data frame. Now we have 9,48,000 records. We can also check the shape. of this data set, df.shape. Okay. Now again, if we check for the missing values using this same function, I will copy this and paste below, run this. Here we can notice city column has no missing value now. Okay. Next we will consider the items count column. Here we have about 33,000 missing values. And as this column is of numerical data type, we can fill the missing value with mean, median or mode, anything you want. I will consider to fill the missing values with mode. To fill the missing value, we have a function known as fillAny function. First of all, we will consider the items count column. Items count. On this column, we will use the fillAny function. FillAny, we will consider the items column. Here, items count, and we will use the mode function to get the mode of this column like this. Okay, you can save this in any variable, like suppose I will save this in x equal to, it will show the mode of this particular column. And when we will see x, this is our mode. 19 is the mode of the items count column. You can simply put x here also, or you can put this command also here. Okay. Now if we run this, it will show the result like this. The values are not filled with the mode. The reason is because when we use the mode function, it does not return a single value. It returns a series. Here you can see we have a series output here. And if we check the type of x, it is a series where we have index which is 0 and the value which is 19. Now as we have to consider the value which is present at index number 0, so using indexing we will put 0 here. It will consider the value 19 that is present at index number 0. And when you will run this, it will show the output like this. And to make the changes permanently, we can simply use one more function which is in place function. We will put in place equal to true, and it will make the changes permanently. And running this, the command is executed. We can remove the spaces here. I am explaining this code once again. We have to fill the missing values with mode. First of all, we have to consider the items count column. Then we have to use the fillAny function on this. Inside this function, we have to pass the value that we want to fill. As we want to fill with mode, first we calculate the mode of this column, and it is 19 here. But here the output is in series format, so we have to use the indexing to get the value of 19 from index 0. That's why we put index 0 here. Okay, it will take out the 19 value, and at last we put the in place equal to true to make the changes permanently. The command is executed, and if we check the sum of missing values again by copying and pasting this command, here you can see in items count column we don't have any missing value. All the missing values are filled with the mode of this particular column. Next we will consider the customer rating column and delivery partner rating column to fill the missing values of these columns. We will fill the missing values of these two columns with the group wise mean or median. Let's see how. As you all know, if we check the mean of this column customer rating, then it will consider all the values at once and give the means of this column. But in case of group wise column, here we will consider the company column to make the group of all different companies, and we will check what rating is given to the orders of that particular company. Like we will make the group of customer ratings for Blinkit orders from Blinkit company, and then we can make the group of customer rating for JioMart to check the rating given to the JioMart orders, like that. For this we will use the group by function, and first we will consider the company column to make the group of each company. Okay, and after this we have to check the customer rating. So we will pass our second column as customer rating only. Customer rating, okay. And this time, instead of using mean function directly, we have to use the transform function here first. The transform function, and inside this we have to use the lambda function x and x. Here we will fill the x with fill na. We will use the fill na function, and we will fill the with mean. Let's understand this again. We have grouped all the different companies using group by function, and after this we are considering the customer rating column to get the mean for this column for each group, okay. And on this we are using the transform function. Let's see from the notes what is transform function, and you can simply type transform, and here we can see that this function is used to combine the output of an aggregation function with the data frame. And this is the syntax: our data frame name dot group by function, and column 1 which is our company, then column 2 which is customer rating, and then transform function. Now after using the transform function, we have to use the lambda function here, and we will check for the lambda function in our Python notes. Lambda, and this is about lambda function. It is a single line function, and this is the syntax here. After using the lambda function, we have filled the missing values with the mean here, and you can run this now. The command is executed. Now we will make these changes in our actual column, which is customer rating. So we will consider the customer rating column like this, and run this again. The command is executed. You can ignore this warning, okay. Now if we check the missing values again by copying and paste it, you can see there is no missing value in our customer rating column, okay. Now similarly we will use the group wise mean imputation for filling the missing values in delivery partner rating column. Here also we will use the group by function, but this time we will consider the group for delivery time. Let's have a look at our data frame first. Here we will make the group of all delivery times, okay. And for this I will copy and paste here, because this column will be best suited to fill the missing values, because as you all know, the delivery partner ratings are highly dependent on their delivery time. Next we will consider the delivery partner rating, and here like this. On this we will use the transform function, and here also we will use the lambda function. Now instead of x I am giving y here, y dot fill na, and we will fill the mean. This time also we will consider mean of the delivery partner rating column. When you will run this, it is showing an error because it is transform. And run this again. The command is executed. We can save the out result in our actual column. The delivery partner rating, consider the column here like this, and equal to this one. The command is executed. Now if we check for the missing value again, after filling the delivery partner rating, you can see it is still showing the 76 missing value. To fill these 76 remaining values, you have to consider this column again, and on this column you have to use the fill na function. Let's consider this column, and here we will simply use the fill na function, and we will fill the mean of this column now. So we will find out the mean and fill it with the mean, okay, like this. Here you are using the fill na function on this column, and you are filling the missing values with the mean of this column like this. And we can run this now. The command is executed, and we can save the output in our actual column name. So I am copying this and paste here the column name. and run this again. The command is executed. Ignore this warning. And finally, if we check for the missing values, you can see there will be no missing value now. Okay, that's how we can fill the missing values with the mean or median of any particular column. Here you can use the median also instead of mean, but I am using the mean only. And notice one thing, at first we have used the transform function to fill the missing values with mean, but when we have some values missing, we haven't used the transform function. We have directly used the fill any function. If you want to check the information about our dataset using info function, then this time here we have 9,48,000 non-null values in each column. Means there is no null value in any column, but there may be outliers in any column. So we will check for the outliers now. The best way to check the outliers in a data frame is the box plot. We will draw the box plot. Let's set the size of our box plot using figure function and fixed size parameter. Let's say the size will be 15 by 6 and we will draw the box plot of our data frame. So simply we have to write data frame and box plot function. When you will run this, it will show the box plot of all numerical columns. This is the box plot of this data frame. Here in order ID column, we can see there we have extremely high values because in order ID we have all unique IDs up to 1 million. For this, we have to not consider this order ID column in our box plot. We will draw a box plot without the order ID column. Again, first set the size of the figure. I am copying this. The size is set to 15 by 6 and now we will drop the order ID column to draw the box plot. We will consider data frame and to drop any column we can simply use drop function. Inside this we have to mention that we want to drop the columns. So I have written columns here, and what column we want to drop? We want to drop the order ID column. It will consider the data frame without the order ID column. On this data frame we can draw the box plot using box plot function. This is our box plot without order ID column. Here we can easily see that we have multiple outliers in the order value column. In a single quick commerce order, we have the 14,000 order value, which can be possible or which can be not possible. But in our case here, we will not consider these order values which are about 14,000. Okay. There are many methods to remove the outliers. One method is percentile capping method, which is mostly used in the industry. In this method, for example, we will make all the values that are above 2500 to 2500 only. Okay, means we will put a cap on the order value. In case you want to consider this method, then I am showing you how to consider this. First of all, we have to consider the order value column. On this we have to use the clip function to clip down all the values below a particular value. Here we are setting the upper limit as 2500. Okay, means using this command all the values that are above 2500 will become equal to 2500 only. And finally you can save this in the actual column like this, and it will clip down all the values. I am not running this. I will show you a different method. The second method is filtering. We will filter out all the records, those order values which are below 2500. For this, first of all, we have to consider the order value column, and here using the comparison operators, we will filter out all the values which are below or equal to 2500 only, and we will put this in square brackets, and to get the output in data frame format we have to use df here and running this. Here in this data frame we have only those records where the order value is equal to or below 2500. Means we have removed all those records where we have the outliers. Now we can save this result in our actual data frame df here, and this is our df. Here you can see the number of records are decreased now. Here we have only 9,47,000 records. Earlier, how many records we had? We had 9,48,000 records. Okay. Now again we will draw the box plot but without the order ID column. So you can simply copy and paste. Here we will use plt.show and run this. This is our box plot. Now after modifying this data, we will draw the box plot again. I will copy this and paste again. This time we will make the horizontal box plot using the parameter vertical equal to false. And in this box plot we will also show the mean for each column. So we will pass show means equal to true. We will run this. It will draw a horizontal box plot this time. Okay, that will show the mean value for each column also. This is our horizontal box plot. Here if you see, for order value column we have the outliers, but these are below the value of 2500 that we set. Okay, we can consider these outliers because there are not too much value for a single order. And here we can see this triangle is showing, if I zoom it, this triangle is showing the mean value for this particular column order value, and for all columns we have triangle which is representing the mean of that particular column. And as you all know, first I will show you the describe function. Here if we consider this order value column, the mean is 570 which is represented by this triangle, and the minimum value is 50 which is represented by this line. Okay, and the maximum value is 2492 which is represented by this one. This middle line between the box represents the median which is equal to 50 percentile which is 531. Okay, now we can consider this data frame for our analysis part. When we will check our information about the data set, here we can see that the order ID column is of integer data type, but it must be of categorical data type, or you can say object data type. Also the order value is in float format and the other columns are also in float format. We will change the data type of these columns. First of all, we will change the data type of order ID column from integer to float. For this, to change the data type, we have to use the as type function. We will consider the order ID column. On this column, we will use as type function to change the data type of any column, and we want the data type as string, so we will pass str here. When we will run this, it will show the output like this, and here you can see data type is object now, or string. We will save this in our actual column which is order ID like this. Okay, and running this, the changes are done in this column. If we see the data frame here, this is our order ID column. Now we will change the data type of this column order value. Here you can see the order values are in float format up to 5 decimal point. So we will change this order value into integer and we will round off the value. We will start with rounding of the float values. First column is our order value. Let's consider order value column. On this column we will use the round function from numpy library. Numpy np dot round function. Inside this function we will pass the column name which is order value. When you will run this, it will show the output like this. We will save the changes in our original column. which is this one. I will copy this and paste here. The changes are done. Now if we have a look at our data frame, df, you can see that order values are round off now. We will do the same thing with other columns as well. Here second column we have considered is delivery time in minutes, this column, and then we have round off the distance column, this one, and the customer rating column, this one, and at last delivery partner rating column. Okay, so all these column values will be round off, and when I will run this, the command is executed, and if we have a look at our data frame now, you can see all the values are round off. Here one thing you can notice, in these columns, order value, delivery minutes, there is no value after the decimal, but in distance column we have one value after the decimal, because while rounding off this distance column I have put 1 here because I want the values up to 1 decimal point only. Okay, if you put 2 here, then it will round off the value up to 2 decimal point, like this. You can put 1, 2, 3 in any of the column. Now we can easily change the data type of float columns to integer. First column we will consider is order value. Order value, on this column we will use the hash type function, and inside this we will pass the integer. Okay, because we want the order value into integer format, like this, and we will save the result in actual column. So I will copy and paste it again, like this. The changes are done. Here if we have a look at our data frame now, I am running this command again. You can see order values are in integer format now. We will do the same thing with other float columns as well. We are changing the data type of delivery time column into integer, changing the data type of item counts column into integer, customer rating also integer format, and delivery partner rating also integer format. And run this command again. The command is executed, and have a look at our data frame. This is the data frame here. All the values are in integer format, but we have kept the distance in float format up to 1 decimal point. And also the customer rating and delivery partner rating are in integer format. While we check the data structure using the info function and run this, the data type of order ID is object now, and customer is order value, distance, and these all are integer format, and also customer rating and delivery partner rating of integer data type. Now we can say our data is modified and cleaned now for data analytics purpose. We will save this cleaned and modified data set in our system. For this you have to pass a path here. Suppose I want to save this data set in this folder. I will copy its path, and we will choose any variable name, new path, and here we will pass the path. Okay, and before this you can simply pass small r here to remove any Unicode error, and at the end of this path you have to give the file name that you want to choose, and before the file name you have to put the forward slash, and here you can notice there are backward slash. Okay, and you have to give the file name. I am naming the file as quick commerce data modified cleaned .csv. Run this. The command is executed. We will save this into CSV format, data frame, and we will use to CSV. Inside this we have to pass the file path. Our file path is stored in new path variable. We will pass new path here. Okay, and we don't need the index in our data set, so we will give index equal to false, and run this again. The command is executed, means our file is saved in our system. Here if we go to data folder, you can see this is our modified and clean data set. Now we will use this in our project. As we are working in this same Jupyter notebook for the project, so we can simply call our data set from here. But in case if you will work in new notebook later, then you have to load this dataset again. Here we will load the cleaned and modified dataset again in this Jupyter notebook. And to do this, as you all know, pd.read underscore csv, and here we have to pass the file path. I will copy its path and paste there. Here, okay, you have to pass small r here, and we will save this in df. Okay, run this. The file is loaded, and this is our final data set. Here we have 9,47,752 rows and 13 columns. Moving ahead to the main part of this project, answering the business questions. Our first question here is, which quick commerce platform has the highest total revenue? Let's have a look at our data set. We have to consider the company column, and we have to tell which company has the highest total revenue. To answer this question, we have to make the group of companies first and calculate the sum of their total order values. Start with group by our data frame, group by, and group by the column company. Okay, and second column we have to consider is order value. To get their sum, we will use the sum function. Okay, and we will save this. When I will run this right now, it will show all the companies and their total order value. It is showing the result neither in ascending or descending format. We can sort this as per our requirement. First, I will save this in a variable name, company revenue. You can give any variable name to it. Copy this, and this is our company revenue. Now we will sort this output, company revenue, and to sort this output we have to use the sort values function. Run this. Here we can see JioMart have the least revenue while Swiggy Instamart have the highest revenue. And then we have Dunzo, Amazon Now, Flipkart Minutes, Big Basket, Zepto, Blinkit, and the highest is for Swiggy Instamart. We will show this output in the form of a graph. We will use the bar chart and the line chart. Let's first set the size of the figure, plt.figure, and fixed size equal to 8 by 5. You can give any size to it. Now we will draw a bar chart for this output. Okay, let's consider this company revenue, and here we will pass plot function, and first kind of plot we need is bar. Okay, and at last we will show plt.show. When you will run this, it will show the bar chart simple like this. Here you can easily see Swiggy and Instamart have the highest revenue while JioMart have the lowest revenue. Now we will modify this bar graph. Let's first make the color of each bar different. We will highlight this highest bar with green color and this lowest bar with red color, and other remaining bars we will highlight with olive color. Okay, for this we have to set the maximum and minimum revenue. Maximum value will be from here, this output. I will copy this and paste here. From this output we will choose the maximum value using the max function. Similarly, we will choose the minimum value using the minimum function. Okay, next we will assign the color to these bars based on the values. For this we will choose the colors. Let's say we will give the green color when the value is maximum. Green if value is maximum. Our maximum value is stored in this variable max value. Okay, if the value is maximum, it will choose this one, and else we will give the red color in case the value is minimum. So red if value equal to this one, the minimum value. Copy this and paste here. And else for other remaining bars we are considering the olive color, and at last we have to give the for loop for value in company revenue. We will give the green color if the value is maximum, else we will give the red color if the value is minimum, and for other remaining bars we will give the olive color. This is our color palette for this bar graph. We will pass this color palette to our bar graph using the parameter color. I will pass simply colors here, and when we will run this is our bar chart. Here the highest bar is of green color and lowest bar is of red color. We can also set the width of this bar using the width parameter. I am setting as 0.3 only. The width is decreased. Now to make this bar more attractive, we can draw a line chart also on this company revenue dot plot, and this time we will select the a line chart. Okay, and run this. You can see it is drawing a line chart also above these bars. Here we can give one more parameter, like we can give the color of these lines as black, and we can give the marker. We can change the marker to asterisk sign and run this again. The asterisks, these are the markers and this is the black line. And finally we will give the title, X label and Y label to this chart. Using plt.xlabel, we are giving the X label as quick commerce platform and the font size is set to 12. Using plt.ylabel, we have set the Y label as total revenue, font size also 12, and the title of this chart will be total revenue by quick commerce platform. And at last we have set the rotation of S-ticks as 45 degree, and we have set the horizontal alignment as right. Now when we will run this, here we have the Y labels total revenue, we have the X label quick commerce platforms, and this is our title total revenue by quick commerce platform. And here you can see that these are the S-ticks and the rotation is 45 degree. We can make this chart more attractive by removing this top border and the right border. For this we have to do some coding here again. First of all, we have to set one variable ax equal to plt.gca. gca means get current axis. You have to learn this. We will select this top border. For this ax dot, we will use the spines and the top. Okay, and this time we will use the function set visible, and we will set this as false only. When I will run this now, you can see that the top border is removed. Similarly, we can remove the right border. Copy this and paste again, and this time we will put right here and run this. You can see the right border is also removed. At last we will pass plt dot tight layout and run this. This is our final graph. Moving to the question. The question is, which quick commerce platform has the highest total revenue? We can easily see that Swiggy Instamart has the highest total revenue. Moving to the question number 2. Question number 2 is, which platform has the highest average order value? Let's have a look at the data frame again. This time we will group the data with respect to company column, and we will check out the mean of order value for each group. df dot group by, and for company column our second column will be order value, because we have to check the average order value. On this we will use the mean function. It will give the average order value for each company. Amazon now has average order value of 557, Blinkit 609, Swiggy Instamart 644. Okay, we will sort this output using the sort value function. I can copy this again and paste here. On this time we will use the sort values function and run this again. Here we can see JioMart have the least average order value, which is 482, while Swiggy Instamart has the highest average order value, which is 644. Now we will draw a stem chart to show the result. For this, first of all, we will save this output in any variable. I am naming the variable as average order value, or in capital average order value, this one, and this is our average order value. Okay, now we will draw a stem chart. First, we will set the size of the figure using figure function. The size of the figure is set as 10 by 4. Now we will use matplotlib library plt.stem. Inside this, we have to pass the value for our x-axis and y-axis. On x-axis, we need the company names, while on y-axis, we need the average order value. If I show you the type of this average order value variable, then type AOV, it is a series. Okay, in series, as you know, we have indexes and we have values. So the company name are indexes and these are the values. On x-axis, we need the indexes from this output. Okay, and on y-axis, we need values. We will also write the plt.show and run this. This is our stem chart. Here by default the stems are sorted in ascending order. Geomart have the lowest average order value while Saving Instamart has the highest order value. We can modify this chart as well. We will give the X level and Y level and the title to this chart. The X level is given as quick commerce platforms. Y level we have average order value in Indian rupees. The title is average order value by quick commerce platform. Okay. Then we have set the rotation and alignment for the X text. Now we will run this. You can see on Y axis we have average order value. On X axis we have the company names and there is 30-degree alignment and it is a right alignment. Okay, this is the title average order value by quick commerce platform. We can do one more thing here. In the above chart, we remove the top and right border. In this chart, we will make the outer border thick. For this, again, we will use ax equal to plt.gca. Now we will highlight the all four borders of this chart. Now ax.spines, first set the top spine, and this time we will use the set line width function. On this, I am setting the line width as 4 and run this. You can see the top line width is set as 4. Similarly, we can set the width for all borders. This time you can say bottom and the right and left. Run this. Now this is our final stem chart for this question. Moving to the next question. Question number 3 is, how does customer rating vary across the platforms? Here we have to consider the company column and the customer rating column. First, we will use the group by function on this company column and find out the average customer rating. Data frame dot group by function. Here consider the company column. The second column we have to consider is customer rating and we have to find out the mean of the customer rating. So I am using mean function and running this. The output is not sorted, so we have to use the sort value function to sort this. Sort values function. On this, here we can see that Dunzo has least customer rating while Blinkit has the highest average customer rating, which is 3.5, while Dunzo has 2.4 only, and these are the ratings for other companies. Now we will show these ratings using a box plot. To draw a box plot, consider our data frame. On this, use the function box plot function. Inside this, we have to pass the value. Our first parameter here we can use is column. We want to use the customer rating column to show the average customer rating, and we will use the second parameter by we want to show the rating by company names. So we will pass company here. We will also pass the one more parameter, which is show means, to show the mean for each company. At last, we will use plt.titleLayout to auto adjust the spacing and plt.show. Run this, it will draw a box plot like this. The customer rating, and these are the company names. Here we cannot read the company names easily. We will modify this plot. First, give the title to this plot using plt.title. Here I am using the title as customer rating distribution across platforms. We have to mention the X label and Y label. plt.X label. Here we will mention platform company. Okay. We have to also pass the Y label. The Y label is given as customer rating because on Y axis we have the ratings. Next, we will do with the X ticks. The rotation will be as usual 30° here, and horizontal alignment will be right. Run this now. We can see that the company names are easily readable now. Amazon now, Big Basket, Zepto. Okay. On X level we have platform, or you can say company. On Y axis we have customer rating. Here you can see it is showing box plot grouped by company as the super title of this plot, while the title is customer rating distribution across platform that we set here. We can also replace this super title. We will use the plt.sup means super and title. As we have to remove this super title, we will simply pass blank here. With this, we can remove the default pandas title and run this again. That title is gone now. So this is the final box plot representing the customer rating across various platforms. Here we can notice that these green triangles are representing the mean. As we can see that the highest mean is for Blinkit, which is above 3.5. It means Blinkit is satisfying its customer highly, and the least mean customer rating is for Dunzo, which is below 2.5. And the ratings for Blinkit are varying from a range of 3 to 5, while the customers rating for Dunzo are varying from 1 up to 3 only, and the ratings for other platform are between 2 to 4. Okay, and these triangles are representing the mean rating for each platform. Next, we can also check the count of the ratings which are given by the customer to these companies. Here in this box plot, we can only check the ranges. But if we want to check how many customer give 3 rating to Blinkit, then we have to check the count. Also, if we want to check how many customers give 2 ratings to Dunzo, then we have to check the count. Let's see how. For this, we have to group 2 columns data. First one is company and second one is customer rating. Data frame dot group by function, and this time we will group 2 columns. So we have to pass square brackets and mention the column names. First column is company and second column is customer rating. I will show you the data frame. We are using this company column and this customer rating column. After this, we have to use the size function. Running this, it will show the output like this. For Amazon, it is showing each rating 1 to 5 and the count for each rating. Okay. Similarly for Big Basket and other companies. Now we have to arrange this data in the form of a table, or you can say data frame. For this, we have to use the unstack function. After this, unstack, and here we have to mention fill value equal to 0. Okay. Unstack means it will reshape the output into a table format, and inside this we have to mention fill value equal to 0. The reason to put this here is if a company has no orders for a particular rating. Okay. then pandas would normally put not a number there. And after using this fill n equal to 0, it will replace those missing value with 0. Running this, and this is our output. Here we can easily read the company names and the ratings and their counts. For Amazon, one rating is given by 15,977 members or customers. And similarly for GeoMart, if we check, rating 5 is given by only 8067 customers. In the above box plot, we could only check the ranges of the ratings for each company, but here we can also check the count for each rating with respect to companies. Now we will show this output in the form of a bar graph. For this, let's first save this code into a variable for later use. I am naming the variable as grouped rating. You can give any variable name, and this is our grouped rating. Okay. Now as we have to draw a bar chart for this grouped rating, simply we will consider this grouped rating, and here we will use the plot function, and we will pass the kind equal to bar. At last, there will be plt.titleAuth and plt.show. When I will run it now, it will show the output like this. On x-axis, we have name of the companies. On y-axis, we have the count for each rating. And here, this is the legend customer rating. Blue color representing rating 1. Here we can see Dunzo has the highest blue color, means highest rating of 1. While purple color or violet color is representing 5. Here we can see Blinkit is representing the highest purple bar for 5 rating. Now we will customize this bar chart also. First of all, we will give the X label. X label we can give company name. We will give the Y label, plt dot Y label. Y label we can give number of ratings, or you can say count of ratings. Then we will give the title. The title is distribution of customer ratings across platforms, and as you can see, this legend is overlapping on this graph. So we have to move this legend out of this graph. For this, we have to do plt dot legend. The title will be same, title equal to customer rating. After this, we have to set one more parameter, which is bbox to anchor. It will tell matplotlib library where we have to place the legend. Here we have to pass the position. Suppose I am giving the position as 1,1 first. We will give the location also. Location will be upper left. I will explain this code once again to you. And when you will run this, here you can see that this legend is now out of the bar plot. Here this parameter bbox to anchor is telling the matplotlib where we have to put this legend. We are putting this legend 1,1 means here. As we have mentioned here, 1,1 means right and top. Okay, when I will mention 1,0, then it will be at right but will be at bottom. We have to put this in the middle here, so we can simply pass 0.5 here, but still it is not in the middle, so we can give it as 0.7. Now this is our final output. The title is distribution of customer rating across platform. Here we can easily see the count of each rating for every company. The company names are in vertical position now. We can change their position using the X ticks, and we have to give the rotation. I am giving the 30. Then horizontal alignment will be right as usual, and run this again. It will look like this. Let's move to the next question. Question number 4. Question 4 is, does delivery time affects the delivery partner ratings? From this you can understand that if the delivery of the order is late, then the customer give lowest rating, while in case if the delivery is fast, then the customer might give the highest rating. Let's have a look at the data frame again. This is the data set. First check the mean delivery time using the mean function. We will consider this delivery time in minutes, and on this we will use the mean function. It is the mean delivery time across all cities and across all companies, 16.5 minutes. Now we will check the mean delivery partner rating. Consider this column and use mean function on this as well. And this is the mean rating given to the delivery partners by the customers, and it is 3.8. It is the mean rating across all cities, across all platforms. Now we will calculate the average rating for each delivery timing. For this we have to use the group by function, df dot group by. First of all we have to use the column for which we want to make the groups, and I want to make the group for delivery timing, and as we need the mean of the ratings, so next column we will consider the delivery partner rating. After this we have to use the mean function. It is showing when the delivery time is 5 minutes, the average rating is 3.8, while if the delivery time is 20 minutes, the average rating given by customers is 3.8. Okay, and when the delivery time is 40, the average rating is 3.7. From this we can easily notice that there is no defect on the delivery partner ratings based on the delivery time. We can also check the correlation between these two columns. We have to consider our first column, and then we have to use the correlation function. Then we have to consider our second column, which is delivery partner ratings. Okay, and we will run this. It is showing a negative correlation, but it is almost equal to 0. It means these two columns are not correlated with each other. There is only a little difference in the ratings based on the delivery time. We can show this using a line chart also. For this we will save this. Okay, we will save this in any variable. I am naming the variable as x only. Okay, and using this x, this one, we will draw a line chart. We will run this, and x dot plot, and at last as usual plt dot tight layout and plt dot show. When I will run this now, it will show a line chart like this. We can modify this. I am putting the marker here, marker equal to asterisk sign, and it is the output. We have to also mention the x label and y label, the title for this chart. Here the x label is given as delivery time in minutes, which will be shown on x-axis. On y-axis we will have average delivery partner rating, and the title of the plot is impact of delivery time on delivery partner rating. Run this again. The title, the y label, and the x label. Here we can also mention the grid using plt.grid, and here we have to pass true. Okay, it will show a grid like structure here. Now from this chart we can notice that if the delivery time is 5 minutes, the average rating is about 3.8, something like this. But when the delivery time is about 40 minutes, which is the highest, the average rating is only a little lower, which is 3.74 only. It means there is no much difference on the partner ratings based on the delivery time. Next, we can make this line chart more efficient by putting these delivery time in groups using the buckets. For this, we will use the cut function from the notes. Let's see about the cut function. Here cut. The cut function is used to convert the numeric data into categorical data of a column, and this is the syntax of this function. Here pd dot cut function. Our first parameter will be column name that we want to consider. We want to make the group for delivery time, so I will consider this column. The next is we have to pass the bins. how many bins we need, or you can say the range of the groups. Our first group will be from 0 to 10. Okay, then we will have group 10 to 20, then 20 to 30, then 30 to 40, and at last 40 to 50. Okay, this is our second parameter. The third parameter we have to pass as labels. For this, labels equal to, suppose for 0 to 10 minutes we will mention very fast delivery. So very fast delivery will be given to 0 to 10 group. Next, for 10 to 20 minutes we will give fast delivery, and for 20 to 30 minutes we will give as normal delivery, and for 30 to 40 minutes we will give slow delivery, and above 40 minutes we will give very slow delivery. We can adjust this code like this. Then we have bins, and then we have labels. Okay, and we will save this result in a new column name. I am naming the column as delivery time bucket, and delivery time bucket will be equal to this one. Running this, the command is executed and a new column delivery time bucket is created in our dataset. Let's first explain this code again to you. This is the syntax for cut function. pd.cut we have used here. Then we have to pass the column name that we want to consider. It is the numerical column name, delivery time. Then we have to pass the bins, or you can say the range, 0 to 10, 10 to 20, and so on. At last we have to pass the labels, which will be our categorical values for these bins. Now have a look at our data frame. Now you can see at last we have new column delivery time bucket. When the delivery time is 19, it is showing that it is a fast delivery. When the delivery time is 6, it is showing that the delivery time is very fast delivery. Okay, and so on, because we have set if the delivery time is 0 to 10, it will show very fast delivery. So here the delivery time is 6, it is showing very fast delivery. Now as we did above, here we have checked the average rating for each delivery time. Now we can check the average rating for each delivery bucket. I can copy this code again, and we will make changes in it only. Here instead of delivery time minutes, we will pass this column name, delivery time bucket, and paste here. Also we can change the variable name. This time I am naming the variable as bucket average, and here also bucket average to show the output. Running this, it is showing delivery ratings for each bucket. When the delivery is very fast, the delivery rating is 3.8, and when there is slow delivery, the average delivery rating is 3.7 only, means there is only a little change. And for very slow delivery, it is showing not a number. It means there is no time in this bucket, and this bucket we set the timing for 40 to 50 minutes. We will check the highest delivery time from here. Dot max, it is showing it is up to 40 only. Okay, but for very slow delivery we have set the bucket as 41 minutes to 50 minutes. That's why it is showing not a number for very slow delivery here. Now we will see this output in the form of a graph. First set the size of the figure. The size is set to 8 by 5. Then we have to consider this bucket average, and using this we will draw a plot using plot function, and at the end we have to use plt.show and run this. It will show a simple line chart like this. On x-axis we have delivery, very fast, fast, normal and slow. On y-axis we have the ratings. We can customize this chart using different parameters. The first parameter we are using as asterisk only, and the second parameter we can use the size of this marker. The size is set as 15, and then the color, we have setting the color as purple. Running this, it will change the color of this line and it will add the markers. These stars are the markers. Next, we will give the X label, Y label and title. Using plt.x label, we have given the X label delivery time buckets in minutes, and then Y label is average delivery partner rating. The title of this chart is impact of delivery time on delivery partner rating, and the last one is grade equal to true. It will show a grade also. Running this is our final chart. Now we can say that when we grouped delivery time into buckets, we observed a clear drop in average ratings. It confirms that faster delivery directly improves the customer satisfaction. Here, our analysis clearly shows that as delivery time increases, delivery partner ratings tend to drop, and it highlights that how critical fast delivery is in quick commerce industry. Moving to the next question. Question number 5 is, what is the most popular product category on Swiggy Instamart for the people of age between 30 to 40 in Mumbai city? For this question, we have to use the filtering based on different conditions and different columns. First of all, we will filter out the company Swiggy Instamart. For this, we have to consider the company column. Our first condition will be company will be Swiggy Instamart. So I will copy this and paste here. Okay, this is our first condition. We will put this condition in round brackets. Next is for the people of age between 30 and 40, means the age should be greater than or equal to 30 but less than 40, and we will use the AND operator and put our second condition. For this, we will use the customer age column. Customer age should be greater than or equal to 30. This is our one condition, and I will copy this again and paste here, or it should be less than 40. Simply customer is less than 40. Okay, these two conditions will be combined to make our second condition. Okay, we will put these two in the round brackets as well using the AND operator again, and we will pass our third condition. The third condition is the city is Mumbai. For this, we will consider the city column, and here we have to choose Mumbai. Okay, this is our third condition. Now we will put all these three conditions in square brackets here and here also, square bracket closed, and we will modify this to make it more easily readable. And before this, we have to pass our data frame name df, and when you will run this, it will show the required output. Here the company name is Swiggy Instamart only, the customer age is between 30 to 40, and the city will be Mumbai only. Okay, there are total 2325 records. Now we have to save this output in an variable. I am naming the variable as data frame product category because we have to find out the most popular product category. This is how we can customize or modify this code, and df pc will be this one. From this data frame, we have to find the most popular product category. For this, we can simply use the value count function, which is one of the important function. The most popular product category will be that which has the highest number of orders received. For this, we will first of all consider this filtered data frame PC and then we will consider the required column, which is product category, and on this we will use the value counts function like this. Here it is sorted in descending order. The highest product category is at the top, means dairy product have the maximum number of orders. Then we have fruit and vegetables, 343 orders, and at last we have beverages where we have only 299 orders. So the answer of this question is dairy is the most popular product category on Swiggy Instamart for the people of age between 30 to 40 in Mumbai city. Okay, that's how we can use the filtering to find the required output from the data frame. Moving to the next question. Question number 6 is, which cities should these company expand into based on their performance? The company which is performing better will definitely expand its business in cities. First of all, have a look at our data set. We have to consider the city column and the company column. Based on these two columns, we will calculate the multiple metrics. Let's see. Here we can use the head function. Now we will group the data with respect to these two columns, company and city, and we will apply the aggregate functions. The performance of the companies will be calculated on the total number of order received, and it will be calculated the average rating given by the customers, and it will be calculated on average delivery time, and at last we will consider the total revenue for each company. Let's first group the data. Group by. Here we will group the data with respect to two columns, company and city. First column company and second column city. Okay, and this time we will use the aggregate function because we have to consider multiple columns at once. Let's first check the count of total orders for each company and in different cities. So we can give total orders equal to, we will consider order ID column, and we will get the count of the order IDs using the count function. And next we will consider the average ratings, average rating for each company in each city. For this we will consider the customer ratings column, and we will use the mean here. Okay, then we also check the average delivery time for each company in each city. This time we will consider the delivery time column. Here also we will use the mean function. Next, at last we will check the total revenue for each company, and it will be shown by the order value column. Order value, and here we will check the sum. Okay, and the function closed. I will explain this code to you again. First run this, it will show the output like this. Here we have the company names, and then we have cities, then we have the new columns for this particular table. The first one is total orders. Here we have considered the order ID column and the count of order IDs. Here we can see for Amazon Now company in Amritsar city, the total orders are 9,929. Similarly, for Japto in Mumbai, the count of order is 9861. Okay. Then we have second column average rating, where we have the average customer rating, and similarly for Chennai, the average customer rating for Amazon Now is 2.9, and for Japto it is 3.2 in Noida, and so on. Okay. Then we have the average delivery time. For this we have considered the delivery time column, and this is the average delivery time for different companies and different cities. At last, we have the total revenue based on the order value column for different companies in different cities. For Zepto, if we check the revenue for Pune city, then this is the amount. So based on this table, we will find out the best performing company, and we will save this in any variable like city, or you can say performance. In this aggregate function, these are the column names for new table, and this is the column that we want to consider for the output, and this is the function that we want to apply on that particular column. Running this again, and in city performance we have this one. Now we will filter out the best cities based on particular condition. Best cities will be, here we will consider this table city performance, and inside this we will put our conditions. Our first condition can be, we want average rating must be greater than or equal to 3.5. We will simply copy this and we will consider this city performance. Here our column average rating, and the condition is it should be greater than or equal to 3.5. This is our first condition. We will put this condition in round brackets. Then we will put our second condition. Our second condition can be, we need average delivery time should be less than or equal to 15. For this we will consider our second column, which is average delivery time. It should be less than or equal to 15 minutes. This is our second condition. Put this in round brackets as well. After the AND operator, we will put our third condition. The third condition we can put that the total orders should be greater than the median value of all total orders. Okay. For this we will consider the total orders column, orders, and it should be greater than the median of this column. We have selected this column. On this we will use median function. So these are our three conditions. Run this, the command is executed, and when we will print the best cities depending on these conditions, it is showing the company, the Blinkit, and Zepto only. Blinkit should expand its business in Amritsar, Chennai, Gurgaon, Kolkata, and Pune, while Zepto should expand its business in Bangalore city. And these are the conditions that we have set. We will select anyone. Suppose for Blinkit we select this Chennai city. Here we can check that the total orders are 9876, which is greater than the median of the total orders. Next, we have set the average rating should be greater than or equal to 3.5. It is 3.58. Next condition, the average time we set should be less than or equal to 15 minutes. Here the average time is 14.13. And in the last we have the total revenue, for which we haven't set any condition. From this output we can get only the company name and city. From here we will pass company, and second we will pass city. Running this, here it is showing an error. The reason is, while we defined the city performance, we haven't used the reset index function here. When we have used reset index and run this, now we will compare this output. Here you can see the company and city are in two different columns now. We have to run this again, and we have to run this again. After this, the company and city are in two different columns. Now we will run this. and the command is executed, we can see that we have company, Blinkit and the cities. Then we have Zepto and the city is Bangalore. Now using the Seaborn library, we will draw a simple bar plot, SNS dot bar plot, and here our data will be this one, bash cities. On x-axis we will have city, on y-axis we will have total revenue, okay, and the parameter hue will be company. We can give the edge color also to the bars. Edge color, suppose I give yellow color to the bars. At last we will have to mention plt.show. This is the simple bar graph representing city on x-axis and their total revenue. We can modify this. First we can set the size of the figure. The size is set as 10 by 3. Running this again, the size is increased. We can also set the legend. The legend you can see is overlapping on this bar. We have to move this legend out of this chart as we did above. For this we have to use plt.legend function. Inside this we will pass title. The title will remain same, company, and after this we have to use b box to anchor parameter. Okay, here we have to pass the position for our legend. I am passing 1, 1 and running this, it will be shown legend here. Okay, 1 means at the top and 1 means at the right. From this bar graph we can notice that this orange bar is representing Zepto and it is for Bangalore city, and this much is the total revenue for this Zepto company in Bangalore city. Similarly, these 5 bars are representing Blinkit in different cities. Moving to the next question. Question number 7 is, are discounts increasing order value or they are just reducing the revenue for the companies? Have a look at the data set. In this data set, we have to consider this discount applied column and the order value for the total revenue. Okay. Let's first count the number of orders on which discount was applied and on which discount was not applied. For this, we will consider this column, discount applied, copy and paste here. After this, we have to use the value count function. Running this, it is showing 0 and 1. 0 is representing that the discount is not applied, 1 is representing discount is applied. For 0, we have total orders about 5,67,000, while for 1 means when the discount was applied, we have order count as 3,79,000. It means we have more orders without the discounts. Now we will group our data and we will calculate the average order value for discount applied and for discount not applied. Data frame, group by function, and we will consider the discount applied column. On this we will use the order value column and we have to check the mean, so we will use the mean function. Here the average order value when the discount was not applied is 476, while when the discount was applied on the orders, the average order value increased to 712. We will save this output in any variable, copy, paste and run. Okay. Next, we will calculate the sum of the item counts when the discount was applied and discount was not applied. We will group the data with respect to same discount applied column, and this time we will consider this column items count to get the sum items count, and here we have to use the sum function. I will run this. It will show when discount was not applied, the item counts was this much, and when the discount was applied, the item count was this much, which is less. From these two outputs, we can notice when the discount was applied, the average order value is increased, but the count of items in the order is decreased. It may be because there may be discount on the costlier items only. That's why the average order value is increased while the number of items is decreased. We will save this output in any variable like discount items count, copy and paste it. Now we will draw two different charts representing these two outputs. For first graph, we will consider this discount order value, and using this we will draw the a bar chart plot and kind equal to bar. Okay, and at the end we have to mention plt.show. Let's run this. It is showing two different bars. First one is for discount not applied, second one is discount applied. Okay, and when the discount was applied, the average order value was about 700, and for the other bar it is about 475. We will modify this bar graph. We will add some parameters. I am adding the width as 0.3, and we can also add the edge color as red. Run this now. The width is decreased and edge color is red set. Now we can give different color to these bars. We have to set the color palette. So colors equal to, using C1 library, we will use color palette function, and we can set the color palette as cool warm. You can set it as per your choice, and here we have to set the length. The length will be equal to 2 because we have two values 0 and 1. So for this we have to mention the length first. The length will be equal to the unique items of this column, discount applied, and in this column we have two unique items which is 1 and 0. We will save this in a variable x, and when we will print x, we have 1 and 0. Now we can put this x here. It will take automatically these two values to represent these two bars. Now we have to mention the color parameter here, and our color will be equal to this what we set here. And when we will run this now, you can see these two bars are in different color now. We can give the title to this bar plt dot title, and here average order value. This is the title. Similarly, we will draw a second plot here. Okay, for this we have to consider this as a subplot, plt dot subplot and 2 comma 2 comma first plot, and we will also increase the size of the figure using figure function plt dot, and here we will set the size as 12 by 8. And first I will run this. Okay, now here we will draw the second subplot. We can simply copy this and paste here, and we will make the required changes here. plt dot subplot 2 comma 2, and we will pass 2 here for second subplot, and this time we will consider this output. So replace it with discount items count. The plot will be bar plot, and width will be same. The edge color will be same as red, or you can put here yellow y. Okay, and the color will be same, the color palette from C1 library. And running this, here we have two different bar charts. First one is for average order value, second one is for average item counts. So we have to rename this average items count. Okay. From these charts, we can easily observe that when discount was applied, the average order value increased, and when the discount was applied, the average item count was decreased. Question number 8 is which company has the best operational efficiency, and it will be calculated by delivery time versus order volume. The best company will have higher order volume and least average delivery time. Let's have a look at the data frame. Here we will consider the delivery time column and order value column. Here we will use the group by function and we will apply it on company column. After this, we have to use the aggregate function. Here we will consider these two parameters. First one is delivery time and second is order volume. Order volume we can check with the order ID column. For this, here we have to use the order ID column. Suppose I am naming the new column as total orders, and we have to consider the order ID column, and we need the count, how much order we have for each company. Second, we will consider the delivery time. For this, we can name the column as average delivery time, and from this data frame we will consider this column and we will check the mean of the delivery time. Okay, and we will put here, and this time we will use the reset index function at the end, and running this, it is showing an error because we have to put a comma here, and running this again, it will show a table like this. Here we have company names, then we have new column name, total orders, and average delivery time with respect to these company names. We will save this result in any variable. I am naming the variable as company efficiency. Copy this and paste. Okay, this is the company efficiency table. In this table we have different companies and the total orders count for each company and their average delivery time. We have to take the decision based on this company efficiency table, but before this we have to scale the values of these two columns. Why scaling is needed here? Because you have two very different type of numbers. First one is for total orders, which is very high, and second one is for average delivery time, which is very low with respect to this column. Okay, for example, we have total orders about 1 lakhs, okay, but the delivery time is 18 only, so there is a very huge difference. Now if we combine these two columns directly, then the values of the total orders will dominate the calculation. So here we have the need for scaling the data. We will normalize the values for fair comparison. For this, from sklearn library, sklearn dot preprocessing module, we will import the a class which is mean max scaler. We will import this class. I can run this right now. The command is executed. In next step, we will scale both the columns to the same range between 0 and 1 so that they can be fairly compared and combined with each other. First of all, we will create a scaling object, and you can name the object as scaler only, and here we will use the mean max scaler function. Here we are creating a scaling object. In the next step, we will create two more new columns in this table, and first of all we will consider this table, this data frame you can say, and to create new columns we have to put double square brackets, and suppose the first column name will be total orders scaled, and the second column name average delivery time scaled. Okay, and in this column what we want, we will use this scalar object. This scalar object will use the min max scalar function, where we have to put function sign. Okay, from scalar we will use the fit transform function, and inside this function we will pass these two already existing column names. Okay, the company efficiency and our first column total orders, and our second column average delivery time. And close the square brackets here. Okay, and the function is also closed. When we will run this, it is showing an error, which is common here, because while considering more than one column we have to put two square brackets. I missed one square bracket here. And run this again, the command is executed. If we have a look at our newly formed data frame with two different columns, here we have the scaling columns. Here we have new columns with scaling values between 0 and 1. Total orders scaled and average delivery time scaled. Okay, now we can use this company efficiency data frame. In this, we will create a new column that will represent the efficiency score, means higher order but lower delivery time. To create the new column, consider our actual data frame, and we have to pass the new column name. The new column name will be efficiency score, and inside this column what we want the difference of these two columns. For this, again we have to consider this column total orders scaled minus this column average delivery time scaled. So copy this first, and then we have to paste the column name average delivery time scaled. Okay, run this, the command is executed, and have a look at company efficiency table again. We have the efficiency score. We will sort this table with respect to the efficiency score. Company efficiency dot sort values, and inside this we have to pass the column name by which we want to sort this entire data frame or entire table. We want to sort with efficiency score. I can copy this and paste here, and we want to sort in descending order, so we will pass ascending equal to false and run this. Here you can see that Zepto has the highest efficiency score while Geomart have the lowest efficiency score. So we can say that Zepto has the highest, or you can say best, operational efficiency, while Geomart has the lowest operational efficiency. Now we will show this efficiency score of various companies using a graph. For this, first of all, we will save the output in any variable, suppose efficiency. Okay, and like this. Now we will draw a bar graph to show this company efficiency score. PLT dot bar, and here we have to choose the company on x-axis and efficiency score on y-axis from this output. Okay, so we will write efficiency, and here we will select companies column, and for y-axis we will select efficiency score column. After this, we will use the grid function to show the grids in our chart, and tight layout function and plt.show. Run this, it will show a bar graph like this. In the middle we have 0. On downward side we have some company efficiency score in negative, and we have some efficiency score in positive. We will modify this plot as per our requirement. We will put X label, Y label and the title. On X-axis we will mention company, on Y-axis we will mention the efficiency score, and the title here will be operational efficiency by the companies. And run this again. We can see we have X label, Y label and the title. We also need to modify this X text because the names of the companies are not readable. For this we will use the xtext function from matplotlib library. Xtext. Here we have to pass parameter rotation to set the rotation of the labels. I am setting as 30°, and when we will run this, the output will be like this. Japto, Blinkit, and still there is some mismatch. For this we will pass one more parameter, which is horizontal alignment equal to right, and run this again. Now we can easily read that Zepto has the highest efficiency score, then we have Blinkit, then Flipkart Minutes, then Dunzo, and we have Swiggy Instamart, the negative efficiency score. Then Big Basket, Amazon Now, and JioMart has the most negative efficiency score. Here if we check Swiggy Instamart efficiency score from this table, we can see it is about minus 0.14614 only. From this graph, it is easily notable that Zepto has the best operational efficiency among these companies. Now we will draw a very interactive plot to show this output using the Plotly library. We will draw a scatter bubble plot. Okay. First of all, we have to import the Plotly library in the Jupyter notebook. Import plotly dot express as px and run this. The library is imported in our Jupyter notebook. Now we will start drawing the plot. We will save the plot in variable figure fig. Okay, we will use plotly library px, and from here we will use the scatter plot. To draw this scatter plot, we will consider the same data which is stored in this variable, and we will pass here. Let's have a look at this data frame. We will consider this data. On x-axis of the chart, we will use total orders column, total orders, this one. On y-axis, we will use this column, average delivery time. As we are drawing a scatter bubble plot, for this first we have to set the size of the bubbles based on the efficiency scores. From this efficiency score, we will choose the minimum efficiency first, efficiency, and we will consider this column, and from efficiency score we will select the minimum efficiency. We will save this in any variable. Suppose the variable name can be minimum efficiency only, and at next we will add a new column in this table, the bubble size. To enter a new column in the data frame, we have to consider the data frame name, then our new column name. Our new column name can be bubble size, and in this column we need, from efficiency table we will select efficiency score, and we will subtract the minimum efficiency which is stored in this variable, minimum efficiency, and here we will add a value of 0.1. okay, in this line we select the minimum efficiency score and save the output in minimum efficiency variable. At next, we created a new column in this table. The column name is bubble size, and in this column we will have this value. Coming back to our bubble plot, next parameter will be size. Here the size of the bubble will be equal to this one, the bubble size. Next parameter is color, that will give the color to the bubbles, and it will depend on the company names, so we can pass company here. It is a column name company. Next will be the text that will be mentioned on the bubbles, and it will also be the company name, so we can use company column here. Next, the title for the chart. The title is set as operational efficiency of quick commerce platforms. The next parameter here, we can use the hover data. When we will hover on any bubble, it will show some data related to this bubble. For each bubble, we want to show total orders. So we will set total orders. This is the column name we are using and it will be true. Next, we can show average delivery time and we will show the average delivery time up to 2 decimal point. For this, we have to mention 2F. Okay. Next, we can choose the efficiency score, means this column, and we also want efficiency score to show up to 3 decimal point. For this, we can use like this colon dot 3F. Okay. We have to pass the parameters for this hover data in the form of a dictionary. Here we have the keys. These column names are the keys for the dictionary and then we have the values. Okay, this is the format of dictionary. Now we will run this command to show how our scatter plot will look like. Then we will make the necessary changes if required. Figure dot show. While we use matplotlib library, we write plt.show. This time we are using the plotly library, so we have to mention figure.show and run this. It is showing an error and the error in size parameter. Here the bubble size, here we have put the small s, but actually it is capital S. So I am making the changes and run this again. This is our scatter bubble chart. Here we have company names represented by the bubbles. It is showing company name, total order value and average delivery time up to 2 decimal point. Then we have bubble size that we set above and last we have the efficiency score up to 3 decimal point only. First, increase the size of these bubbles because they are looking very small. So we can pass one parameter here, that will be size max, and we can give any size here. I am giving 40 and run this again. The size of the bubbles is increased now. As Zepto have the maximum efficiency, so the bubble size is the largest, while Geomart have the bubble size smallest. Next, we can make the labels more cleaner. For this, figure dot update traces function, and here we have to pass text position equal to middle center. Okay, next we will do one more thing. We will improve the layout of this bubble chart. For this, figure dot update layout, and here we will pass some parameters. First, we will replace the title for our x-axis and the new title will be total orders, higher is better. Okay, then we will replace the title for our y-axis and the title for y-axis will be average delivery time in minutes and lower is better. Next, we will set the position of this graph title, and for this we will use title underscore x equal to some value between 0 to 1. When I am using 0.5, it will move the title in the middle of this graph. When we will put 0, the title will be on the left side, and if we put 1, the title will be on the right side. Next, we can change the template of this plot using the template parameter. And at last, we will set the height of this chart using the height parameter, and we can set the height as 600. And when we will run this finally, this is the plot in dark theme, or you can say dark template. Here we have company names and with their different colors, different size of bubbles. Largest bubble is for Zepto having the highest efficiency score. Lowest bubble is for Geomart having the lowest efficiency score. Now this Zepto company having the highest efficiency score, it should be shown on the upper side while this Geomart should be shown on lower side. So we will reverse the values of this y-axis. We are reversing y-axis so that best performance appear higher, and for this we will use figure dot update y-axis. and here we will use the parameter auto range. Auto range will be set as reversed. Run this. This is our final chart where we have operational efficiency of quick commerce platforms. On x-axis we have total orders, and we can say that higher order value is better. On y-axis we have delivery time in minutes, and we can say that lower delivery time is better. And these different bubbles are representing different companies. Zepto is at the top with the highest efficiency score, while Geomart is at bottom with lowest efficiency score. If we want to check the efficiency score or other values for other companies, you can see company Blinkit. The total order is 118.887K and average delivery time is about 15.12 minutes. The bubble size and efficiency score. Similarly, for Amazon now, the total orders, average delivery time is 18.98 and so on. That's how we can draw the scatter bubble plot using Plotly library. Now we will draw a mini dashboard for this project. Let's create the dashboard. In this dashboard, we will create 4 different cards that will represent 4 different calculations, and we will also have the 4 different bar charts. First of all, we will create the dashboard layout. We will set the size of our dashboard. We will set the size of the dashboard as 12 by 12. Okay, means a large size. Now using the Seaborn library SNS, we will set the style and we will use the white grid. So I will pass white grid here. Next we will do some KPI calculation. KPI means key performance indicators. Here we will create 4 different cards that will represent 4 different KPIs. First one we will create for the total count of order IDs. Okay, that will give us the total order volume. Then we will create the KPI 4 to calculate the total order value. Next we will create to mention the average delivery time, and the fourth will be that will mention the average customer rating. For this we have to consider first column order ID, and we will mention the total order ID, so I will use count function. We will save this in any variable. I am naming the variable as total orders. Okay, next we will create to mention the total order value, so we will consider the order value, and here we will use the sum function to get the sum of total. We will save this also in a variable total revenue. The third one we will create for to mention the average delivery time. For this we will consider the column delivery. Let's have a look at the data frame. We will consider this column delivery time minute. Okay, so we can paste it directly, and we will apply the mean function on this to get the average. The fourth and last KPI will be to mention the customer rating. Data frame customer rating, we will get the average of this also. We will use the mean function. We will save this in variable average delivery time, and this one we will save in variable average rating. Okay, so these are our 4 KPIs. I am removing this data frame. Now we will create the KPI cards. We will show all 4 cards in one single horizontal line. PLT dot, we will use subplot and subplot to grid function. Here I will pass 3 by 4 and then 0 by 0 means for first card. Then we have to mention PLT dot axis of and PLT dot text 0.5 and 0.6, and the text will be our this one total orders in our first KPI card, and colon and comma. Okay, next we will set the font size. I am setting the size as 15, and the alignment of the text will be center. Okay, now we will use plt.text, and here this time again 0.5, 0.3 this time, and total orders and font size will be suppose 15. I will run this to show you the first KPI card. At end we will use the plt.titleLayout and plt.show. When we will run this, it is showing error because we have to put this without quotes, and run this again. This is the rough view of our first KPI card. Here we have set the position of a text 0.5, 0.6. If we change it, suppose 0.1, then you can see the position of text is moved to left. So we have kept 0.5. Next 0.6, if we change it to 0.1, the position will be moved down. Okay, so we have set 0.6 here. Next we have mentioned total orders. It is the variable total orders, and in this variable this value is stored, which is shown here 947752. Next we have set the font size, which is 25, and the alignment is at the center of the card. And next text is for this, you can say heading, it is set 0.5. If we change it 0.1, then you can see the change, it is moved to left. So I have set 0.5. Similarly we have set 0.4 for vertical spacing. And next the text that we want to give to this card is total orders, which is mentioned here, and font size is 15. Here when we are running this text is not aligned with this value, so we will align it. For this we will use the parameter horizontal alignment, and here we will pass center. And with this we will also use the parameter font style to style the font in italic. And next parameter we can use is font weight to make it bold. Font weight equal to bold. When we will run this again, it will show an error because I have used E here, and run this again, so it will look like this. This card is representing the count of total orders. Similarly, we will create our second KPI card for total revenue. I will copy this from here and paste here. In this we will make the change from 00 to 01 to change the position of our card. Next we will do the same, plt not axis and off. Next we will use the same, but here we, instead of total orders, we will mention total revenue. We will delete this total order, and in place of this we will mention total revenue for our second card, like this. And we will also put the rupee symbol. This is our second KPI card that is mentioning the total revenue, and here we also have the symbol of rupee. Similarly, we will create our third KPI card. I will copy this again. I will copy the first line only first, and this time we will make the change to 0, 2. Okay, and we will copy the second line and paste, and the third line the same. And here instead of total revenue we will mention average delivery time for our third card, and we will remove the rupee symbol also. We will delete this total revenue, and here we will apply the average delivery time from here, that will mention the average delivery time based on this calculation. Okay, and the colon, the font size and alignment will be same, center. At last we will copy our fourth line and paste here. The position will be same, 0.5, 0.4. Instead of total revenue we will mention average delivery time, average delivery time. Other parameters will remain same, and run this. The third card is showing average delivery time, but you can see it is not round off. We have to round off this value up to 2 decimal point. For this we have to use 0.2f here. it will round off this value up to 2 decimal point. Run this again. It is showing an error because we have to remove this comma also, and run this again. Now we have the average delivery time, which is 16.51 minutes. Next, we will create the fourth KPI card for average customer rating. Again, we will copy and paste here. This time we will choose 0, 3. Okay, and we will copy this also and paste again, and we will copy our third line and make the required changes. 0.5, 0.6 will remain same. Instead of average delivery time, we will mention average rating, which is our this variable. You can copy and paste directly to avoid any error. Average rating, and the rating will be also up to 2 decimal points, so we have used 2f here. The font size and alignment will remain same. At last we will copy and modify the last line 0.5, 0.4, and this time average customer rating we will mention. The other parameters will remain same. Run this, and this is our fourth KPI card, that is mentioning average customer rating, which is 3.04. Next, we will create the company level matrices that will be based on the different companies. First of all, we will apply the group by function on company column, df.group by, and we will consider the column company. After this, we will use the aggregate function to get the calculation for different columns. And first of all, we will use the order ID column to get the total count of orders. First, we will get the order records, and for this we have to consider the order ID column, and we have to get the total count, so I will use count function. Next, we have to consider the revenue. For this, we will consider the order value column, and we will get the sum of all order values using the sum function. Next, we will consider the average delivery time. For this, we will consider the delivery time column, round brackets, and the column name delivery time minutes. This is our column name, if you remember, and we have to calculate the mean, so I will use mean function. At last, we have to select the customer ratings. For this, we will choose the customer rating column. After this, we will use the mean function to calculate the average customer rating. And at last, we will use reset index function. If we check our notes why we use this reset index function, then we will go to our notes and paste reset index, and it is showing that to convert the index of a series into a column to form a data frame. It means when we have used reset index function on this code, then we will get the output in the form of a data frame. Now we will save this in a variable. I will name the variable company matrix and equal to this one. Okay, and running this, it is showing an error. The error is we have to put comma here and here also. Run this again. It is showing error again. It is showing mean. Okay, we have used mean function here, but we have to write mean only. Customer rating and mean. Okay, now we will run this again. This time the command is executed, and if we see how will our company matrix will look, copy and paste here, and it will look like a table. Here, as we have group by with company, it is showing company here, and then we have order columns, revenue, average delivery time, average rating. So these 4 columns are shown here, and these are the values that we have mentioned here: the count, sum, mean, and mean. And at last, the use of reset index make this table into a form of a data frame. We can delete this as of now, and we will move forward. Now we will create our charts for this dashboard. The first chart that we will draw is orders by company. Plt dot subplot, because we have to draw 4 different plots here, so we have to use subplot function. Subplot to grid, and here we will pass the position of the chart and the size of the chart 3,2 and 1,0. This is the position, and we will use the SNS library, C1 library, to draw the bar plot, and we will pass the parameter our data is stored in this company matrix, so we will consider this data. Okay, next we will pass the x-axis. On x-axis we will keep company column. Let's have a look at our data again. We will use this company column on our x-axis for our first plot. Okay, and on y-axis we will keep the orders, because we are drawing a chart orders by company, so we will consider the orders column, that is this one. Okay, and next we will mention the title and hashtags for this chart. The title for this chart, I have chosen orders by company. The font size of the title will be 20, and as we did above, we have mentioned the hashtags, their rotation and alignment. If we run this, then you can see this is our first chart. We will modify it also, and on y-axis we have orders, on x-axis we have company. This chart is showing total order count for each of the company. Next we will draw our second plot. Our second plot will be revenue by company. I will copy this and paste here again, and this time the size of the chart will remain same 3/2, but the position will be changed and it will be 1,1. Okay, and again we will use the C1 library. I will copy and paste here. Inside this the data will remain same. On x-axis we will have company, but on y-axis we don't have orders. Instead we will take the revenue, so we will consider this second column the revenue. Okay, and this revenue is same that we have mentioned here. Then we have to put the title and hashtags. I will copy this and paste here. We have to make little changes here. The old title is orders by company, we have to change it revenue by company. Font size will remain same and all other parameters will remain same. Run this. Here we have our second chart, that is representing revenue by company. On x-axis we have company name, and on y-axis we have the sum of total revenue for each company. Next we will draw our third chart for the average delivery time. Average delivery time by company. We will copy this first line again, and the size of the chart will remain same, but the position will change this time. This time the position will be 2/0. Next we will use the C1 library to draw our third bar plot. The data will be company matrix same. X-axis we will have company. On y-axis we will have average delivery time, which is our third column. You can copy from here or you can copy from here, average delivery time, and we will replace it here. And they will have title hashtags. I will copy paste here, and here we have to change the title. I will change the title as average delivery time by company, and hashtags will remain same. Run this. It will show our third chart. It is representing average delivery time by different companies. On x-axis we have company name. On y-axis we have the average delivery time for these companies. Here we can see JioMart has the highest average delivery time. Similarly, we will draw our fourth plot that will represent the customer rating. Okay, average rating by company. We will copy this. I am copying all 4 lines and pasting here, and we will make the changes accordingly. Subplot to grid, the size will remain same 3/2, but the position will change to 2/1. Okay, and it will be a bar plot also. Data will remain same. X-axis company will remain same, Here we have to change the y-axis value. On y-axis we will have average rating. So we will replace it with average rating. And the title will be changed. Here instead of average delivery time we will mention average customer rating by company. And font size and asterisks will remain same. Run this. It will show the all 4 charts, and this is our fourth chart, average customer rating by company. On y-axis we have the average customer rating. Here we can see Blinkit has the highest average customer rating while Dunzo have lowest customer rating. So that's how we can create 4 KPI cards and 4 subplot in our dashboard. We will modify it more. We will give a title to this dashboard. For this we have to first set the font style where we can include the emojis in the title. For this we will use plt.rc parameters, and here we will choose font family and we will give the font that we want. We will select this font for our dashboard title. Next we will give the title to dashboard using subtitle, means super title, and here we will pass the title for our dashboard. Here we will pass the title. The title is Quick Commerce KPI Dashboard. Here you can see different emojis we have used like shopping basket, and we have the box and the car which is showing the delivery and packets. Next we can set the size of this title as 24, and also you can set the color for this title. I am setting the color as navy. You can give the color of your choice. When running this, it is showing an error. We have to put font dot family and run this again. This is our dashboard, and here we have the title Quick Commerce KPI Dashboard. I am removing this table. Now we can also mention a subtitle below this super title using the plt dot big text, and here we will pass the position 0.5 and 0.94. Okay, and then we will pass the subtitle. This is our subtitle which is mentioning business overview, the revenue, delivery, experience. And here we have the emojis also, and these emojis are included in this font. We can also set the font size. First of all we will set the alignment as center. Then we will have font size. I am mentioning the font size 12, and we will give the color as gray. Run this, and here you can see this is our subtitle, business overview, revenue, delivery, experience, and the color is gray. Here if we change the position of this subtitle, suppose I mentioned 0.1 and run this again, you can see the position is changed. So I am mentioning here 0.5, and the best position is 0.5 and 0.94 for this dashboard. In this dashboard, if you notice, then there is very little space between these two bars. We can set this horizontal space by using plt dot subplots adjust, and here we will have to pass the horizontal space. It is represented by h space, and we will set the horizontal space as 0.7 and run this. Let's see the difference. Now you can see there is some space between these two charts. You have to use this function after the use of tight layout function only. This is our final dashboard. This is the super title, Quick Commerce KPI Dashboard. This is subtitle, and here we have 4 KPI cards representing total orders, total revenue, average delivery time, and average customer rating. And we have 4 different bar plots representing orders by company, revenue by company, average delivery time by company, and average customer rating by company. We can modify this dashboard more and more, but we will do this in our next projects. That's all friends for this video. If you like this project, kindly hit the like button and subscribe to our channel for more upcoming projects. We will upload up to 100 projects in our playlist. If you want to learn data science, you can enroll in our Udemy courses. Our first course is about 13 projects and it is among the top rated courses on Udemy. Second course is Python for data science and our third course is NumPy for data science. The link for these three courses are given in the description of this video.